A uniform chain of length 2 meter is kept on a table such that length of 60 centimeter hangs freely from the edge of the table. The total mass of the chain is 4 kg. What is the work done in pulling the entire chain on the table? And let us see the question. This is basically the table, right? Now what is happening? This is a chain and some part of it is hanging. What part is hanging? The entire length is basically 2 meters, so this will be basically 0.6 meters, and this remaining is 1.4 meter, right? So this is, and the total length is, mass is 4 kg, right? Total mass is 4 kg. What is the work done in pulling the entire chain on the table, right? Now what we are doing is we are pulling this part onto the table itself, right? Now what work we have to do? Let us assume that this point is at potential energy. At this point potential energy is 0, right? Now what is happening? This mass is hanging. Now using center of mass, if you have done a little bit of that, using center of mass, what I can assume that 1.4 kg is lying on it, and this is connected to a thread, basically a massless thread, and this entire mass, what is the mass? The entire mass, that means let us use the unitary method. 2 meter length has a mass of 4 kg, right? That means 0.6 meter will have 4 divided by 2 into 0.6, which will be 1.2 kg, right? So that means 1.2 kg is hanging over here, and where it is hanging, if this length is 0.6, so we can assume that the center of mass will be at this point, which will be 0.3 meter. So I can replace this entire this chain in the form of a massless string which is attached to a block at a height of 0.3, which is basically at the center of mass of the chain, and this block has a mass of 1.2 kg. You're getting my point? This entire chain has a mass of 1.2 kg. We have replaced this chain with this kind of a block, which is placed at a distance of 0.3 meter below the table. And 0.3 meter, why? Because it was the center of mass of the chain, right? So this is basically the question. Now you have to pull this thing, this block, onto the table. How much work needs to be done? So work done will be equal to the change in potential energy, right? So how much potential energy we have to supply? So basically we have to pull in mgh 1.2 into g, basically 10, into h 0.3. This is basically mgh. This much work you need to do so that this block can come on the table. So this will be equal to what? 1.2 into 3, which will be equal to 3.6 joules. So that means option B is correct. Generally what happens is, questions like these seem very difficult, and although these kind of questions will be found in almost every book, you might have done these kind of questions if you have studied well, but the thing is, they are given long methods that are given over there. Are they using integration, etc.? But this is basically a shortcut method. What you do is you just replace the chain by a block which is connected with a massless string, right? You just do this. This is basically a shortcut method. This was a shortcut method, right? You need not do any long cut method especially for AIEEE. You won't be requiring this, right? So this is the shortcut method where you can use this as basically a mass which is kept at a distance at the center of mass of the chain, not at this point. Remember, not at this point. Most of the students will, what they do, they will keep this block at the lowest point, not at the lowest point. You have to keep this at the center of mass, which is basically 0.3 meter below the table, right? So you just place it and you just have to pull it over here. So this is the work done, which is absolutely correct, right?